So we're going to talk about function notation. Function notation can make it simple to express a lot of mathematical instructions, give a lot of mathematical information, but you have to understand the symbols we're using. It says let f of x equal 9 minus 2x. And then it asks us to do two different things. And I've asked you a question over here, are they the same? So the first one says f of 2/5. And I really want you to understand that whatever's in the parentheses here is what they want us to put into our function machine. So we're going to go up here. It says f of x. So instead of x, we have this 2/5, which means in this function, wherever there is an x, we're going to take that out and replace it with 2/5. We're going to have to do some math with fractions, which may be a little messy, but we'll take care of that. Whereas this one says f of 2 over f of 5. Now notice how this is different. This is asking us to put 2 into the function, put 5 into the function, and then whatever results we get, we're going to form a fraction or a division between those two numbers. Okay, so let's start with f of 2/5. F of 2/5. Now our function says f of x equals 9 minus 2x. We are being told that we need to put 2/5 into the function. So we're going to take out that x and we're going to put 2/5 into our function. That is, I'm going to copy that same function, 9 minus 2, but I'm going to take out that x and I'm going to put in my 2/5. I have negative 2 times 2/5. Now if we think way back to fractions, well, remember we have to find a common denominator. So first I'm going to turn the whole number 9 into a fraction. That is 9 over 1. Then I'm going to multiply both the top and the bottom by 5 to give me the fraction 45/5, which I can now subtract 4/5, giving me the final answer, 41/5, or if you prefer, 8.2. All right, so now I want to look at the difference between this problem here. So I'm just going to draw a little line here. The top part of the fraction tells us to find f of 2, that is, take our function, take out the x, and put in a 2. Hopefully, once you churn out the math, you agree with me that the answer here is 5. The bottom of the fraction tells us to run 5 through the function, taking out the x, putting in a 5. So I found f of 2, I found f of 5, and then I'm asked to divide those two. That is 5 divided by -1 in the same order that we did the math here, which gives us our final answer. And we can clearly see that these two are not the same. We got an answer of 8.2 when we ran 2/5 through the function, and we got an answer of -5 when we did f of 2 divided by f of 5. So we're going to take it a step further. In example 2, let f of x equals x squared minus 3x. We're asked to do 4 different things. Find f of 2, find f of h, find f of h plus 2, and finally find f of h plus 2 minus f of 2. Notice all of these instructions are very small and simple, even though they might imply a lot of math that needs to be done. So we're going to start with f of 2. I'm going to bring my function down here. Remember, my function says f of x equals x squared minus 3x, but we're going to take out the x and we're going to put in a 2. And I don't know if I have a superscript button, so I am going to use the caret notation for powers. So I've taken out all of my x's and I'm going to put those 2's in. 2 squared, or 2 to the second power, becomes 2 times 2, which is 4, minus 3 times 2, which is 6, giving me a result of negative 2. F of h, I'm going to bring my function down so we can see it. So here, we're going to perform the same operation that we did before. We're going to take out whatever's in there, which is the x, and we're going to put it in whatever we've been asked to, which in this case is an h. Notice I'm very careful every time I take out a variable, I put in a set of parentheses to maintain proper multiplication and order of operations. So it's no surprise here that my final answer, when I put in h, is very similar to my answer to my original function. F of x, f of h equals, I'm sorry, the writing is so messy here, h squared minus 3h. It's this exact function, x squared minus 3x, with an h in place of the x. Now let's take that one step further and do f of h plus 2 and see how much that complicates things. So here I have my function, x squared minus 3x, with my x's taken out, and I'm putting my h plus 2 inside of those parentheses. This problem becomes much more difficult than when we had a single number because of the squaring. That means there's 2 of these h plus 2 chunks being multiplied together, minus 3 times this other h plus 2 chunk, if you will. Which means I have to distribute the h across the h and the 2, giving me h squared plus 2h, and I have to distribute the 2 across the h and the 2, giving me 2h plus 4. Over here I have to distribute the negative 3 across the h and the 2, giving me negative 3h minus 6. I'm going to clean up a little. This is the only h squared term I have, so I'm going to drop it straight down. Notice I have a 2h, and a negative 3h. These combined give me a positive 4, minus 3, or negative 3h, gives me a positive 1h. And we know when we just have 1, we don't have to list that 1, so it's just a positive h. Then our constants, we have a positive 4 and a negative 6, giving me a constant of a negative 2 at the end. Now again, you would probably write this h squared plus h minus 2. And I would never mark you off for putting that 1 in there, but I would never include it myself. The final problem asks us to find f of h plus 2 minus f of 2. Now, if we look at part C, we've already found f of h plus 2, and we have that answer right down here, h squared plus h minus 2. That is this first chunk right here. We've already gone through the work of doing it in C. We might as well use that down in D. Now we have a minus sign. And then we have this chunk here. Let's do it in red. Please notice that this negative is going to affect everything here. So I'm going to put some parentheses here to remind me that this negative out front affects everything inside of the parentheses. F of 2. Well, if I remember right, in part A, we found f of 2 and got the answer negative 2. This looks like a simple simplification then. h squared as my only squared term, positive h as my only h term, negative 2 minus negative, negative cancel out, make this a positive. Negative 2 plus 2 gives me a 0 on the end, and this is my final answer to D. Hope this helps. Thanks for watching.